Today we're going to revise the area of rectangles. Now it's really important to know the difference between area and perimeter. It's quite easy to mix them up. So I'm just going to start by talking about this. The area is basically the number of centimeters squared or meters squared inside the shape. And the perimeter is the length outside the shape. So they're different things because area and length they're measured in different quantities. How are we going to remember this? Well, A comes before P in the alphabet and I comes before O. So this is how you can remember which way round it is. Now for a rectangle, let's look at this example here. We've got 7 centimeters and 4 centimeters. We can split it up. So we can split up into 7 squares here along here, which we've counted 1, 2, 3, 4, 5, 6, 7, and then 4 up. So we've actually got 4 rows of 7, and that's why it's base times height. You can do 7 times 4. They put a little dot here, but what they mean is times. I'm going to change that. Area is length times width, and we get 28 centimeters squared. So we can imagine splitting up. We're just counting the squares, and there are 28. But we don't want to count the squares in general. So in general, we just have the formula area equals base times height. And then we have that armed in our heads, ready for whenever we see a rectangle, okay? It's not true for any shape. It's not true for a circle or a triangle. These have different formulae, but it is true for a rectangle, and we can use that. And it's really effective. Okay, let's do some examples. So calculate the areas of these two rectangles here. Okay, I've got my base is 3. This would also be 3 down here. I've got my height is 15. So I'm going to always show my working 3 times 15. And I can try and do this in my head. Okay, or I can do it on a calculator. I'm not too worried about that right now. I get 45. Now, what is my unit of measurements? It's not centimeters. It's how many centimeters squared I've got. I've got 45 centimeters squared. You don't have to work in centimeters or meters. Sometimes we use other units. So I put this example here just to demonstrate that. And it would be 12 times 18. Now this is getting a bit more tricky, so you probably get your calculator out for this. But it's a number that you should try and learn how to work out by hand. And here we get 216. But what is it? It's not miles, it's miles squared. All that means is I've split it into these little miles squared, and I've got 216 of them. Okay, just going to talk about some slightly more tricky examples. So here I've got 2 rectangles. By the way, I just remembered a square is basically an example of a rectangle. So it's just when the base and the height are the same. So you can still use this formula for a square. Okay, here we've got missing lengths for 2 rectangles. So it's 7 times something equals 56. Now we've done a bit of practice of this, and you could write that something as maybe an x. Okay, I'm going to replace it by x. So I'm going to get 7x equals 56. I can divide both sides by 7, and I'm going to get x is 56 divided by 7, which I could write as a fraction, and that's going to become 8. Okay, if I work that out on a calculator, or if my times tables I could potentially use. 8 watts, well, I'm back to having a length, so it's 8 kilometers. Really important to be writing our units of measurement in. The other way you could have done this would just be to think, what do I multiply 7 by to get 56? And maybe just written down your 7 times table. Okay, until we got to 56, which would be after the 8th one. That would work. You're basically still solving this equation here though. Okay, this one, 2 times something is 9. Now this is a bit trickier because 2 times 4 is 8, 2 times 5 is 10. It's not going to be a whole number. But what I'm going to do is I'm going to use my equation knowledge. It's going to be 2, because I can do the height times the base. It doesn't matter on the order. I'm going to change this to an x. 2x equals 9. And then I can divide both sides by 2. I really should just write that down actually. Okay, just like I should have written it down here. Divide by 7, divide by 7. Then I'm going to get x is 9 divided by 2, which is 4.5 centimeters. Okay, so I've talked a bit about where the formula comes from. It's really important to have an understanding of it, that it's these number of squares. I've done 2 examples where I've calculated areas, different units, and then I've flipped the problem around. So I've got the area now and I want to find the lengths. Okay, I'm going to do one more example, a very wordy example, and this is why being able to find areas of rectangles is one of the reasons why it's important, because it has practical implications. Let's say I want to tile my bathroom. Well, I don't want to just go out and buy a ridiculous number of tiles, because if I do that, I'm just going to have loads of tiles left over. What am I going to do with them? They're going to take up space. However, I don't just want to buy like one box at a time, because then I'm going to have to go back and forth buying boxes. I don't just want to guess, because again, I might be wrong. I can maybe do a calculation to try and figure it out using maths. So Mrs. Rogers is tiling a bathroom wall. She needs our help. The bathroom wall is 360 centimeters long and 240 centimeters high. Okay, remember, this is 3.6 meters. That sounds about right. That's quite a long length. And then 2.4 meters is a typical height of a room, really, but we're going to work in centimeters. And then each tile is 20 centimeters by 20 centimeters. So we've got square tiles, but squares are examples of rectangles. The tiles are sold in boxes of 6. So not big boxes actually, but we still want to try and work out how many we need. Maybe we'll buy a few extra boxes just in case we break some, but hey, at least we'll know how many boxes we need. Okay, each box costs £8. How much will it cost Mrs. Rogers to tile her bathroom wall? So we know that we're going to put lots of different tiles along here, but I don't want to split it up into tiny little rectangles. I want to work out the areas of these. So the area of the bathroom wall is going to be base times height. It's going to be 360 times 240. I'm going to go back to explain my reasoning. I'm going to find the area of the wall. I'm going to find the area of the tile, and then I can divide to work out how many tiles I need. I can then work out how many boxes I need, and then I can work out the cost, total cost. There's quite a few steps going on here. Okay, so first of all, the area of the bathroom wall, we're going to multiply, and we get a very large number, 86,400 centimeters squared. That seems a very large amount, but it's not actually that big, because the centimeter squared is very small. And then the tiles are 20 centimeter by 20 centimeters. So I'm going to do 20 times 20, which is 400 centimeters squared. Now I've got a big area, I've got a small area. I want to know how many times the small area goes into the big area. I'm going to divide. I'm going to do 86,400 divided by 400, and that is equal to 216. So I need 216 tiles. The tiles are sold in boxes of 6. So boxes, we're going to do 216, the number of tiles, divided by how many tiles are in one box. Hopefully that makes sense. And this is going to be 36. Because if I had 36 boxes of 6 tiles, I would do 36 times 6 to work out the number of tiles. Here I need to divide. So I need 36 boxes. I'm nearly there. Can you feel it? Each box costs £8. Mrs. Rogers needs to know how much it's going to cost her. Okay, because she might need to budget for it. She might not be able to, buy all her bathroom this month. She might need to wait a bit. So cost is going to be £8 times my 36 boxes I need. And that gives me £288. Quite a lot of money for the tiles. I don't know if she's going to try and lay the tiles herself on the wall, or if she's going to pay someone to do it, but that's going to be more money if she does the latter. So she's going to really need to think about this, something you might need to think about in the future. So from knowing the area of a rectangle, we can solve practical problems as well as ones where we're finding the area, or ones where we've got the area and we're finding the length. So I'm going to get you to practice this now.